Hi, today we're going to be solving quadratic inequalities and also graphing quadratic inequalities. And so the front page is just solving quadratic inequalities. Problem number 1 says find the solution of the inequality x squared plus 3x minus 18 is less than 0, and then solve it algebraically. We're going to solve these inequalities like we solved absolute value inequalities in the past. We are going to change it to an equal sign and solve it like you normally would. And then we're going to plot our answers on a number line and do our test section. Okay, so first off, changing it to an equal sign. And we've been dealing a lot with solving quadratics. Now at this level, these should all be factorable. However, if you want to use completing the square method or you want to use the quadratic formula, you definitely can use those methods if you prefer those best. Okay, for this one, this factors, let's see, it's a trinomial, no GCF, begins with a 1. So we have to figure out what multiplies to negative 18 and adds up to 3. And it will become 6 and negative 3. So those are our factors. Setting both sides equal to 0. And if you recall, an inequality has multiple answers. These are just the places where they're equal to 0. So when we have an inequality, we actually are going to expect a range of answers. So we're going to put our number line. We're going to put our numbers on the number line. And then the original inequality was not an equal to, so that's open circles. And then with an inequality, I know that it's going to be a range of answers. So I'm going to test a number in between negative 6 and 3. So let's test 0. And again, you always test it back into the original inequality, which was this. And we get negative 18 less than 0, which is true. And if it's true, it means you shade in between there. And your answer is all the numbers from negative 6 to 3, but not including those. And remember, we write it like this. Negative 6 is less than x is less than 3. All right, so we'll try 2 more of these. Problem number 2, find the solution to that inequality. Again, we're going to set it up like an equal sign. We're going to solve this like normal. It's another inequality that begins, trinomial that begins with a 1. So multiply to make 24 and add up to negative 11. So let's see. We're going to eventually get negative 3 and negative 8. They multiply to make negative 24, and they add up to negative 11. And don't forget, if you're really having problems coming up with the factors, don't forget when we did factoring, I showed you guys to get the table of all the factors. You could do the number you're trying to get, 24 divided by x. That means 24 can be divided by what number? Go to your table, and then you can scroll your table and try to find out which one adds up to negative 11. Again, this is just for the trinomials that begin with a 1. Okay, setting both factors equal to 0. And again, this is an inequality, so it's not just those answers, making my number line. It is an equal or to inequality, so we're going to do closed circles. And then I'm going to test a number. Well, between 3 and 8, I'll just test 5. So my original inequality, going to plug in a 5. And then see what happens. This one I'm going to use my calculator for. Okay, so I get negative 6 less than or equal to 0. That is true again. So it's all the numbers between there, and my final answer is 3 less than or equal to x less than or equal to 8. All right, one more of these. We have x squared plus 3x equals 28. And if you recall, you have to have it in equal 0 form before we start solving. So we need to subtract the 28 over. All right, so again, this is another trinomial that begins with a 1. All right, so if I make my little chart, I need to multiply to make negative 28 and add up to 3. And that will be 7 and negative 4. Okay, so my inequalities, I'm going to make that on a number line. I'll test 0. Oh, and the original inequality did not have an equal sign, so open circles. Let's test 0. Remember, we're going to test it in the original inequality. Okay, that's false. That means the test area is false. We're going to shade out. And then our final answer are all the x's less than negative 7 or all the x's greater than 4. All right, and the other thing we're going to do today is quadratic inequality graphs. So if we turn the page, for number 4, we have y is less than or equal to x squared plus 4x minus 5. So we're going to first start off by realizing, again, that everything is based off of where it's equal. So we're going to start off by first graphing our normal parabola. All right, remember, quadratics are parabolas. There's only 2 differences between a regular equal equation one and these inequality ones. When you're graphing a parabola, we want our U shape to come out. So when you get your table, you don't want to pick any table. So if I just go to my table, I don't want to use specifically just this one because it came up. I want to get that nice U shape. So I'm looking for the pattern where this happens. I want to match, I want to match, I want to match. It also is a good idea to also have your table on your paper. In case you misplot something, I can see your table and what you had wanted to graph. All right, so first off, we're going to start off by graphing those points. So negative 5, 0, negative 4, negative 5, negative 3, negative 8, negative 2, negative 9, and then back up. All right, and this is where we stop with the similarities. After we graph our shell of our parabola, now we have to go back to the original inequality. The original inequality had an equal sign on it. All right, so this right here, that had an equal sign. If it has an equal sign, then we use solid lines. Just like we would use solid points on a number line, we're going to use solid line on here. So that means we are going to connect it with a solid. And the other thing we're going to do is, in fact, you know what? Since we have more space on our graph, it actually might be a better idea if we can actually plot the next set of points up. So let me go back and see. Negative 6 goes to 7. So in fact, I'm going to go up one more. And that means negative or positive 2 would also go to 7. If you can fill up the whole graph, is a good idea to fill up the whole graph unless the directions tell you to particularly stop at certain x values. Now the only other difference now that we have to do is the less than or equal to part. Just like on a number line we would shade on a number line, we're going to shade on the graph. Either we're going to shade inside the graph or we're going to shade outside the graph. And to do this, we are going to, just like a normal in problem we did on the first page, we're going to do a test number. Again, I'm going to pick any point within the parabola. That looks like a good spot. 0, 0 would be the best spot if it's inside. All right, so now what we're going to do is we're going to test it into the original inequality. So I'll write it down first, what it was. Then I'm going to plug in my 0 for y and my 0 for x. And that 0 is not less than or equal to -5. That's false. So if it's false, that means we shade outside, away from the test area. And that's the only difference between a quadratic equation and a quadratic inequality, is how you connect the parabola, solid line or dotted line, and which way you shade, inside the parabola or outside. Okay, so on your calculators, on Inspires, you can do this as well. I guess they're not going to turn off the symbols. So with the 84, in order to do shades, you have to go to the very end, right here, and then you have to press enter until you start getting the shades. This one that looks like it's shading up, that's a greater than. We want a less than, so we have to do the other symbol, which is shade down. And then you can just go ahead and graph, and you will actually see the shades on here. All right, so we'll try this one more time. Okay, on the next problem, it's y greater than, not equal to, x squared minus 6x plus 5. So again, we're first going to start off by doing an equal sign. I'm going to put my graph in. And when you clear yours out, your symbol should switch. I don't know why mine does not. Okay, so x squared minus 6x plus 5. Okay, going to my table. I want that nice pattern out. Okay, so here's my table. All right, I have 0, 5, 1, 0, 2, -3, 3, -4, and then back around again. Okay, so how do I connect this? Well, this inequality, the original one, was like this. Did not have an equal bar. That means just like on a number line we do open circles, I don't want to have a solid line because that would mean equal to. So on these, you're going to use a dotted line to represent not equal to. All right, and then we just have to figure out which way to shade. So I'm going to do my test number. Now, you can pick 0, 0. Basically what happens is if you do 0, 0 and this works, you're going to shade where the test area is, which is outside. And if it doesn't work, you shade inside. Or you can just always stick with inside. So I'll just pick this point right there. This is the point 3, 0. So let's check it. Plug a 0 in for y and a 3 for x. And you'll get 0 is greater than -4, and that is false. Oh, I'm sorry. That is true. 0 is greater than -4. So that's true. That means the test area is all true, so you shade inside. And if you want to see the graph can do it, go back, go all the way over to the end. You're going to hit the symbol until you have the arrow shade up looking one, and then graph, and you will see that it's inside.